In this video, we're going to talk about testing hypotheses about a population proportion, and we're going to do multiple examples of this. If you didn't watch the first video for some reason, you definitely want to go back and understand that we're going to be doing all of these steps and where they come from and why. So we are going to check for H0, H1, the requirements and assumptions, the test statistic, the p-value, and make a decision and conclusion at the end. We're going to follow the same process for every problem. So let's look at this problem here. It says in 2007, 46% of Americans said they do not trust the media when it comes to reporting the news fully, accurately, and fairly. And in a 2017 poll of 1,010 adults nationwide, 525 stated they did not trust the media. At the alpha equals 0.05 level of significance, is there evidence to support the claim that the percentage of Americans that do not trust the media to report fully and accurately has increased since 2007? Okay, so I'm going to write over on this side. Okay, so the first thing we're supposed to do is say what H0 and H1 would be. Now, in this problem, we're dealing with proportions because it started off by giving us a percentage of Americans who said something. So this is qualitative data. So we're going to start with P. And remember, for H0, this is always an equal to. And then I want to go with the, with what we're assuming the population proportion is, which is that from that survey in 2007. So we're going to use 0.46, since it said 46% of Americans did not trust the media. And then we have to decide for the alternative hypothesis. We know the number is going to be the same, 0.46. But what will I put in between? Do I need a not equal to, a greater than, or a less than? Well, when I go back over here, it says, is there evidence to support that Americans who do not trust the media has increased since 2007? So we're going to use a greater than because of that word increased. All right, so we already got H0 and H1. Now we need to check our requirements and assumptions. Requirements/assumptions. Okay. So let's see. First, we need to identify whether this is a simple random sample. Okay. So let's see. Let's go check if it says that somewhere. In a poll of 1,000 nationwide. On this one, it doesn't explicitly say that it's a simple random sample. But what happens with problems like these is unless there's wording to indicate that it's not a simple random sample, we just assume that it is. So that's why sometimes, even though it says requirements, it's also like assumptions. So this is one we're going to assume is true unless stated otherwise. Okay, the second thing that we need to check for is that n times p0 times 1 minus p0 is greater than 10. Okay, so let's check for that. N is right up here, 1,010, and our p0 is at 0.46. Okay, so let's plug in those values. 1010 times 0.46 times 1 minus 0.46. Let's see what we get that. Calculate it. 1010 times 0.46 times 1 minus 0.46. Okay, I got 250.9. Okay, and that is definitely greater than 10, so good on that one. So that means we can, we have assessed normality. This is we can assume that the sample came from a normal population. And then we also want to check to make sure that my sample is less than 5% of the population. So I talked about in my last video, we only have slightly over 1,000 people here. For Americans, there's millions of Americans, right? And so we would at least need 50,000, if not more, in our sample to not meet this condition. So we're good. 1,000 people is definitely less than 5% of the population. Okay, so we checked all of those things. Now we want to find our test statistic and our p-value. So we're going to go to StatCrunch, and we want to go to proportion stats, since we're doing a proportion, one sample. We do not have data in our spreadsheet, so we're going to use summary. For the number of successes, we're going to go to what happened in our sample. 525 people said that they did not trust the media. We're going to treat that as this is the number of individuals who have the characteristic that we're looking for, and the number of observations is our sample size, 1,010. I make sure that the radio button next to hypothesis test is selected, and then for H0 we have P equals, and we're going to change this number to 0.46. And then for the alternative, we said greater than 0.46. And compute. Okay, so at the end of this, we can see our Z statistic is 3.81, and our p-value, it just says less than 0.0001. So this means our p-value is extremely low, and this will typically happen. If our p-value is like super, super, super low, it'll just say less than 0.0001. Okay, and so now we need to make a decision based off of this. Okay, so let's put this over here. All right, I'm going to write down my test statistic, or my Z0, is 3.81, and my p-value is just less than 0.0001. Okay, very small. Okay. So when it comes to the decision, remember we look at our p-value and we're going to compare that to my level of significance. My alpha was 0.05, that's my level of significance. And so we compare these two together. So for my decision, I would say, okay, my p-value is less than alpha. It's very small, definitely less than 0.05. Okay, so when our p-value is less than alpha, that means we will reject H0. So that's our official decision. Now comes the conclusion part. Okay, so I have to go back to my hypotheses. I am rejecting H0. So that means we are not believing that that's true anymore. And that means we're going to go with the alternative. So we'll say that P is greater than 0.46. But when I give my conclusion, I want to put this back into words. And so we would say there is significant evidence at the alpha equals 0.05 significance level of significance. To conclude, okay, and we're saying our proportion is greater than 0.46, but I'm not going to say that. I want to say what my problem is about. So to conclude that the percentage of Americans that do not trust the media has increased since 2007. Okay. Another thing we could have said at the end is percentage of Americans that do not trust the media is greater than 46%. So we could also say that. But even though it feels like a lot to write that, you should be writing a statement similar to this every time you do a hypothesis test. So you would say there is significant evidence or there is not significant evidence. You state your level of significance, and then you say to conclude that blank, right? And then based on which hypothesis we went with, then we would put that back into context for the problem. So what did that mean for this particular example? Okay. That was kind of a longer example, so I'm going to do a new video for the next one.